This conference will now be recorded.
In this course, we'll be learning completely about the DevOps, like all the DevOps tools, DevOps strategies, DevOps skill set required for a person. You may be an experienced IT person, or you might be a completely from a different background. This course will suit you, right? So you might be a completely a fresher. So how do you fit into DevOps? Or else you might be having so many questions like, I'm a tester for 10 years. I want to switch into DevOps. Will that work? How should we do that? So all those questions will be answered in today's demo. This demo is nothing but the first class wherein we'll get a complete overview of DevOps, like what is DevOps, why DevOps, what are the tools required, what are the skills we need, if this course suits me or not, where I fit into DevOps. So all this you'll get a clear picture, you'll get an overview of what DevOps is all about, right? And let me remind you, not only just learning what is DevOps, this course is completely practical oriented with a complete hands-on on different real scenarios, okay, which we use in the projects. And also this course is designed by keeping in mind all the tools that are demand in the market right now. Okay, the course is updated very frequently with all the latest tools, all the latest strategies implemented in the market. Okay, so that by the end of the day, when you apply for the jobs, you can see a lot of openings. You have a lot of scope for the job, right? So, and also, like I said, there's a complete hands-on, rigorous hands-on will be there. This day, today, it's a first class, so we may be having theoretical part, discussions and all. Tomorrow onwards, complete hands-on will be there. Okay. Can you hear me, all of you? Some of you are asking me to start. It is started. Let me know if you have any issues in audio part. Please check your audio part once. So like I said, the agenda is complete hands-on will be there so that you could gain a lot of confidence working in the projects. Like in my previous batches, many people were selected. Some of them got multiple offers as well. This is all because of the rigorous hands-on. Also, will provide a support through WhatsApp. When you are doing hands-on, we'll create a group for the batch so that you can post your queries with the hands-on. Every day, hands-on is a must. Dedication, hard work, hands-on. These are the things we need from your end. Okay, so just follow the content, put your effort, so that will do. So now let's begin. About the lab setup, about the notes, everything I'll be talking about in few minutes. So let's begin with DevOps overview. Like what is DevOps? Why we need this DevOps? Yeah, where this comes into picture? How it makes a difference? How is it different from the regular or the traditional approaches? So this is a big picture of DevOps. Roles and responsibilities of a DevOps engineer, DevOps delivery pipeline, DevOps tools and skills. Okay, so let's understand all these things. I'm sharing a black screen. Can you all see the screen? Can you all see this?
Yeah.
Yes,
okay.
ma'am.
Sahil, please check audio from your end. Everyone can hear me. You can rejoin or check your audio. Okay. Now let's begin talking about DevOps. So what is this DevOps? Some of you might be having some idea about what this DevOps is all about. You might have heard about this. Give me a second. Or you might be completely new. We'll be going from the basics. So let us try to understand what this DevOps is all about. Say to understand this, let us take development of any software application. Okay, let's say some LinkedIn application or else some Twitter or else some Instagram. Take some application which you use in our daily life. For any application, we are seeing means end users are using the application means there are so many process involved, there were so many teams involved. I'm talking about the very important teams like dev team, QA team and ops team. So let's talk about these three teams and what do they do. Like we know developers write the code, right? They are called programmers or developers, whatever you call them. Testers will be working in testing the code. They will also write the test cases, right? They are called automation test engineers. See, please check the audio part from your end. Some of you audio is not enabled, means you should check the computer audio of your system. Please make sure to check the computer audio. Choose this option. Everyone else is hearing me. Okay, so they write the test cases. They are called automation test engineers. The testing may be manual or by using a tools which is called automation testing. This is the task of QA team. And ops team, what do? They take care of the servers, right? They check the servers are configured properly. They check the services on those servers. They check the logins, access. All this would be taken care by ops team, right? In simple, we can say yes, infrastructure management is done by the ops team. And also if developers have to perform any task, let's say developers have to write the code, right? Or else developers have to check if their code is working or not. Testers have to run the test cases. If these two teams have to do anything, means they need the server services and all, right? So whatever they need will be provided by ops teams. Means ops team will provide the dev team and QA team by providing the infrastructure they need to perform their task. See, here I'm talking about actually the traditional approach. I'm not talking about DevOps yet, okay? I'm talking about the old traditional approach. Then we'll talk about DevOps. So meaning here, what is happening? I'm including QA also on the development team. So let it be development team. So development team, if they have to execute any of their tasks, ops team will provide them with the infrastructure. Means developers have to request them for the infrastructure changes they need. Let's say they need a new operating system or else they need changes to the operating system. They'll raise a request to operations team. Operations team should serve the request. And before ops team serve those requests to the DevOps team, they have to do lot many checks. Because if this change is made, are the servers going to be stable? Are the services going to be up and running? Any network going to be disconnected? All these things ops team have to check, isn't it? Because if something goes wrong, they have to take care of it. So yeah, it takes some quite considerable amount of time. Meanwhile, developers are waiting for the change they need. Ops team are still working to provide the change. And yeah, so here developers don't know why ops team is taking so much time to serve the request. Similarly, ops team doesn't know why developers are requesting all these changes, right? So what happens here? There is some gap between the team. Means there is no proper communication. There is no proper understanding between the teams. Developers don't know why operations team needs so much time to serve the request. Similarly, ops team don't know why developers or QA team need those changes, isn't it? There arises some gap between the teams. And also, not only that, why is this gap actually? Like I said, there is no proper communication, there is no proper understanding. This happens because if you look into these three teams, Dev, QA, and Ops, these are the three teams with a different skill set. Their areas of expertise are different. Their core competences are different. See, if developers, if you take, they are into some programming language, they know how to work with build tools and all. Right? QA people, they'll be working with the test cases, either automation testing tools or manual testing. Right? Similarly, ops teams would be having an idea of monitoring the servers, monitoring the infrastructure, configuring it, deploying the applications and all, right? Their areas of expertise are different. Their core skills are different. Still, they are working in the same process. Hence, there arises the gap between the teams because developers don't have any idea about this monitoring or configuring the server. Similarly, ops teams and vice versa, right? Hence, these three teams are working in the same process with a different skill set, and so there arises some gap between the teams. Okay, this is one reason why DevOps came in, to eliminate the gap. Is that the only reason? There are other reasons also. Let us have a look at it. See, the other reasons are, let's suppose, okay, developers are ready with the code. Testers will test this code, isn't it? Testers will test this code. If any bugs, they'll send to developers. Developers will again fix it and they'll send it to QA. So this process repeats till the application is bug-free or defect-free. Okay, let's suppose, okay, developers have developed it, testers have tested it multiple times. Now the application is bug-free, defect-free. They want to send the application, they want to deploy the application to end users. Who are the end users for the application? So you can unmute and speak out if you have any questions, or if you have any doubts here, you can unmute and speak out. You can also answer the questions. You can unmute and speak about it so that the sessions would be more interactive. So who are the end users of any application?
Clients.
Here, end users could be, yes, like end users could be whoever uses the application. Let's suppose I use Amazon.com. So I'm an end user of Amazon, right? Who uses the application finally? So let's say application is ready. They want to provide the application to end users. So they have to deploy it on some servers and provide it to end users. So here comes ops teams. Means development team and QA team, once the application is ready, they will hand over the application to ops team. Okay, along with the application, they will also hand over the instruction document. Instruction document means, let's say it's a Java application, which version of Java they have used, which operating systems they should use, what servers they should deploy. All this information they'll provide in the instruction document along with the application to the ops team. And ops team have to now configure the servers, install the respective software. Like if the application needs Java, all of them should be installed, right? Also, the right versions of the software should be installed. The application may need some other software, right? Like some other particular versions. Let's say the application needs only Java, or else the application needs only Java 11, Java 8. All the right versions should be installed, right? And also they'll follow this instruction document, but this instruction document provided by developers may be completely different, right? It may not be working on the different operating systems. Let's say developers provided this instruction document for Windows. It might be not working for Linux. So operations team should figure out the steps to configure the servers, should make the application running. It takes quite considerable amount of time, right? All these takes some, not only this, they should also check that application is not having any downtime. By the way, what is meant by downtime? What is meant by downtime of an application?
Like the maintenance period.
Sorry?
Like, for example, if we are doing maintenance or something, you know.
Yeah, see, application should not be down. It should be highly available, right?
Yeah.
So yeah, ops team should be taking care of all these things, which is going to take considerable amount of time. What happens eventually? The deployment process is slowed down. Let's say application is ready in January, in February. It may be deployed and available to end users only in April, right? Because it takes quite considerable amount of time. So eventually the deployment process is slowed down. This is the traditional approach I'm talking about, without DevOps approach. This is what is happening. But if you see our applications which we use regularly, like maybe take some Amazon application or take some Facebook, these are all the best examples which uses DevOps approach. Or else take a LinkedIn, or else a Netflix, or else Instagram, and so on. If you check these applications, you could see the application, the new features very quickly, isn't it? In an overnight, you could see some new feature, right? Or else, let's say immediately they want to make some modifications. Maybe it's a festive season, they want to put some new features, new discounts in Amazon sale, or else let's say there are new features introduced in Facebook. So how could you see those features overnight? Or else, let's say there is an emergency in the country or in the world, there is some pandemic, they have introduced very quickly some new features, right? How is this possible? How could be deployments become so faster when there were so many steps involved? So that's where DevOps is working. Means like in the traditional approach, what is happening? Dev team means I mean QA also. So they are providing the application to ops team. They have to figure out all the steps and do this. But now in the DevOps approach, once the application is ready by Dev and QA team, they will hand over the application to DevOps team. Why DevOps team? What is the difference? DevOps team is nothing but a team who knows the complete process of deploying the application to production. Means once the code is ready, once the code is tested, how to take it to production servers automatically without any manual intervention very quickly. That is all about DevOps. Means I'm repeating, from the desk of a developer till it reaches the production table, there were so many phases involved. All these phases can be automated, and that is what is called DevOps. Means see, okay, developer wrote the code automatically, it should be tested. Means of course test cases will be written by testers. Those test cases should be executed, application should be built, deployed to first staging environments, then pre-prod, and then to prod. All these can be automated. That is what DevOps. So what are the different phases involved here? What are the different strategies involved here? Okay, what are the different tools involved? How can they automate the deployment to production? Right? So all of them are involved in it. So you might be a developer for 10 years, or else let's say you are a tester, you want to switch your career, you want to change your career into DevOps. Yes, if you know this process of automation, if you know the phases, strategies, tools involved in this automation process, yes, you are eligible. If you are completely fresher, or else let's say you are completely from different background of some accounting or medicine and so on, you can just, if you are interested, you can again switch to this DevOps by learning this automation process. In this automation process, strategies, phases, tools, all of them will be learning in our course. Is that making sense? Yeah. So why DevOps came in? First reason is to overcome the gap between the teams. Second reason is to increase the velocity of deployments. Deployments should be faster. Means whenever developer write a code, immediately it should be tested, built, deployed to lower environments, like first to staging environments, then pre-prod, and then prod environment. Okay, so deployment should be faster. That's what companies need. See, almost like every company is trying to implement this DevOps strategies. By 2024, almost every company will be stepping into it. Already gigantic companies like Facebook, Amazon, Netflix, they're all implementing it. In a couple of years, every small company will step into it. It's a process of complete automation, which eliminates the manual work. And because of this automation, deployments were faster. That's what companies need, right? Also qualitative, how they become qualitative, we'll understand as we progress. Faster deployments, qualitative, complete automation, 24/7 automation is possible, which reduces the manual cost, manual resources. So manual resources are reduced means whoever have the skill set, whoever have this automation skills will survive in the market in the near future. So this is the right time to invest your time, invest your effort, and learn such tools which are having great demand in the market. Okay, I have included all the tools. I'll talk about the skill set in few minutes. Which tools are demand in the market, I'll talk about it. So yeah, this is how it works. So eliminates the gap, because see, DevOps team means they know the complete process of automation. Developers, once the code is ready, how to deploy it, they know that. Okay, they know how to do it faster with automation tools like Docker and all. So yeah, there is no gap because they understand what are developers' requirements, how to deploy the application, and also they make the deployments faster. Not only that, overcomes the drawbacks of traditional approaches. Traditional software methodologies, you know, right? Like waterfall methodology. Yeah, it could overcome the drawbacks of that also. Okay, we'll talk about the drawbacks of waterfall methodology and we'll understand the importance of DevOps. Any questions in this part? Understood, everyone? Is this much clear for all of you? A quick confirmation will help me. Any questions you can unmute and speak out, or else message me in the chat window. Anything is fine. Good to go? Okay, all right. So, let's talk about waterfall methodology. Like any SDLs, if you take, I believe you all know software development lifecycle. If anyone new here, let me tell you, it's a sequence of activities involved in development, like requirement gathering, analysis, understand the requirements, design, coding, testing, and delivery, right? It goes in the sequence, each phase after the other. I'm talking about a typical methodology, yes, waterfall methodology, which serve the industry for decades. But still, there are problems faced by both dev team and ops team. Both dev team and ops team face problems because of this. What are the challenges this methodology posed? Anyone? What are the drawbacks of this waterfall methodology?
Waterfall methodology, the process is very slow.
Yes, here the methodology is very slow because see, developers write the code. Immediately it's not going for testing. Okay, they wrote some code. Okay, after 6 months they may test the code. So testers start testing this old code. Meanwhile, developers will be working on the new code. Then after 6 months, testers comes with the bugs in the old code. Developers will have a lot of pressure. They should be working on the new code as well as fix the bugs in the old code. Also, testing done at later stages will be very costly and also time taking. So, slow methodology, not a
Deploy
flexible methodology, because there is no going back. Yeah, suppose you are in design or coding, there is no going back if client comes with the new requirements and all, right? It cannot accommodate new requirements, it cannot accommodate new challenges, right? Also, complete software will be delivered all at once. Maybe let's say they have given requirements in 2020. Okay, let's say 2020. All this development takes some 2 years, 2022. Then only the complete software is delivered. Meanwhile, they don't accept any changes. The model cannot accept the changes, any modifications. But imagine during these 2 years, business might have changed completely, right? It's a customer facing world, right? Always new changes to be accepted. Otherwise, it doesn't work in reality, it doesn't work in the market now. So it doesn't help in any way in today's world. So complete software will be delivered all after 2 years, which client may not need it anymore. So in this way, it faces a lot of challenges to development. Also, ops team also face challenges because it's a slow methodology. They need to maintain the servers running always for a longer time. Maintaining servers uptime for longer duration is again a challenge. Okay, I'm talking about all the manual process. Suppose there are 200 servers. Manually monitoring those servers is again a challenge. If there are 2 or 3 servers, they can log in, check the health of them. But when they have huge infrastructure, that's again a challenge. Configuring this huge infrastructure is also a challenge when they are doing manually, right? They cannot diagnose the issue, they cannot identify the issue. When something goes wrong, it's going to take a lot of time. So these are all the challenges posed by waterfall methodology. How to overcome these challenges? Is there any option to overcome these challenges? To overcome these challenges posed by the waterfall methodology, Agile came into picture. Okay, Agile came into picture. But Agile was successful only to overcome challenges of dev team, but not ops team. Okay, Agile was successful only to this extent. So then came another methodology called Devops. Devops is a methodology which can overcome challenges of both the teams. Understood? This can overcome challenges of both. So that's what is DevOps. But before talking about this, Let us also talk about how waterfall could overcome the challenges. Here, my idea is not to teach you waterfall methodology or like waterfall or agile, but let's have some understanding of it. See, agile can overcome these challenges. How is it possible? Because in agile there were frequent releases. Okay, there will be every week there will be a release, every week or every fortnight there will be a release. Code is always stable and working, right? There are again different terms like sprints, scrum and all. I'm not going into that, but just understand, yes, there'll be frequent releases, code is always stable and working, right? And also like they could accept the changes because every week or every fortnight they could deliver, right? But how is this possible? How can frequent delivery is possible? How is code is always stable and ready for release? Because it implements the concept called continuous development, continuous testing, continuous integration. See, these concepts will be talking in detail with the hands-on and with the demos in the course. Okay, but here let me give you an overview. Continuous development, continuous testing, continuous integration. What is that? See, let's suppose on week 1, developers wrote some code. Okay, week 2, immediately, let's say, see, code will be developed in bits and parts. Let's say they have developed a chunk of code called A. Okay, it was working fine. Okay, let's suppose this is working fine. They have written the code. So in week 2, immediately this chunk of code A will be tested. It's not tested after 6 months. Immediately it will be tested. Meanwhile, developers are not sitting idle. They will be developing another chunk of code called B. Again, week 3, this B will be tested. Again, developers will be developing another bit of code C. But also at some point on week 4, A and B and C will be combined and tested. Then only it's a complete product, isn't it? First, they'll be tested individually. Then they'll also be tested by integrating. This is called continuous integration. If you see, every week development testing are happening parallelly, simultaneously, iteratively, isn't it? So development testing are going on hand in hand, parallelly. This is what is called continuous development and continuous testing, right? Continuous development, continuous testing and continuous integration, right? We'll see practically what is this. So yeah, because of that, it could eliminate the drawbacks of development, but operations team drawbacks were still there. Okay, so that's where DevOps came in. So why DevOps came in? To eliminate the gap between the teams. Okay, because DevOps team can understand the challenges, requirements of every other team, right? And then to make the deployments faster, to increase the velocity of deployments, and also the other thing is to overcome the drawbacks posed by the traditional methodologies, right? That is why DevOps came in. So anyone, whoever can automate the complete process once application code is ready till deployments can be working in the DevOps strategy. Okay, it's a completely a different subject. It will be very interesting. Everyone can fit into it. So what is DevOps now? Till now we
Can you
understood
explain
why
the
DevOps came in.
what
Now
was the
let us
difference?
talk about what is DevOps. Yes, please.
What was the difference between Agile and DevOps?
In Agile, operations tasks were not automated, or else it's not that immediately they were going for deployments. Okay, automation process of the operation tasks like configuring the servers, monitoring the servers, immediately once the application is ready is achieved in DevOps. Let me show you. Till now we understood why DevOps came in, right? So what is DevOps? DevOps is nothing but continuous development, continuous testing, continuous integration, which is there in Agile, along with continuous deployment. This is important. Continuous deployment and continuous monitoring. This is what is DevOps. The term continuous is important. Means these are happening simultaneously, parallelly, or iteratively, whatever you call. Whenever developer write any code, okay, they wrote some code, let's say a bit of code, that will be going for testing, building, integrating, deploy to lower environments like test environments, staging environments, UAT, pre-prod, then prod, finally reaches production. Every new feature means you can see in Amazon, in Facebook, let's say there's a new feature introduced. See, the new feature will go through all this process automatically and see the production servers very quickly. Understood? Let's say Facebook, take a Facebook application. They have developed some new feature. Developers wrote some new feature here. Okay. This new feature will be immediately tested on test environments. Of course, different levels of testing, manual automation happens here. The application will be built, tested, deployed to smaller environments than to the finally production and end users can see. Understood everyone what DevOps is? So if you want me to compare, okay, let us compare it with SDLC. Let us compare it with SL. Let's compare it with the DevOps. Okay, see here, if the main phases are like development. After development, only testing begins. After testing, only deployment and then monitoring. Each happens one after the other, after complete development testing, after complete testing and so on. But here, continuously development testing happens parallelly, iteratively. And then, give me a second, please. Yeah, continuous development, continuous testing, continuous integration, then deployment is again manual and monitoring. After this completed the application. But here, any new feature developed, of course, it's a potential feature. So develop, test, integrate, deploy, and monitor automatically without manual intervention by use of the tools. There were so many tools implemented here, so many strategies implemented to achieve this. Isn't it great? Isn't it sounds great and interesting? Any new feature could hit the production servers automatically in a very less time. Isn't it? Very faster. So that is what is DevOps. So I hope you should be getting an idea of now why DevOps came in. What is it? Any questions here in this part till this much?
Can you just tell us that how DevOps is automated means how the concept came actually for DevOps? Say here with SDLC we can distinguish that Agile fine, but for Agile and DevOps all are same only, but automation came to the picture, right? For DevOps. So can you just give a brief one?
This is the
Yeah.
difference, not automation. This is the difference.
Okay. Configuration. What is the CD full form?
Continuous deployments.
Continuous deployment. Okay. Okay. Okay.
Any more question?
But in Agile also it is CD is written, right?
Continuous deployment without manual intervention. Okay, means
Okay.
continuous deployment in the sense servers can also be configured, deployed. They can be having a good control over. In Agile, maybe implementing, but many manual steps are there. It's not a completely continuous approach. Is not there in Agile. Agile is lacking with the agility in the operations part. You have agility here, but there is no agility here in Agile methodology. That is brought in here. All these phases are integrated. See, we are talking about, we are having an overview here. Once we start the hands-on, we'll be stepping. We are going to create this pipeline. This is called Cicd pipeline, continuous integration, continuous delivery pipeline. We are going to create this pipeline in multiple applications and practically see what happens. Then you can connect the dots. Okay, it's a huge process. To create this pipeline, it takes nearly a month to go through to this step. So many things are to be learned there. So many steps are involved here. This is a high level and an overview of what DevOps is.
Yeah, sure. Thank you. Thank you. Thank you.
Can I ask something?
Yes, please.
So, with the best of my understanding, I believe the difference that you're saying right now is between Agile and DevOps is, for example, if we have any prod server and then you're testing something, for just giving an example, say you just need to make a change as per the VRD, and then you're making adding just an additional feature. Just giving a rough idea, right? So we have existing application, we just need to do like an add-on. So you're testing that add-on on the test server, but I believe, you can correct me if I'm wrong, on the DevOps, you're doing like the same stuff parallelly in terms of images or probably in terms of Docklers. And when you're finally deploying on a test, it is also getting deployed on a prod. This is DevOps or something else?
See here, actually, whenever developer wrote a new feature, that's what you're saying, right? A new feature is developed. Okay.
Is getting
Whenever
new
there's a
features.
new code,
Just
right?
making just making myself more correct. So whatever you are testing right now, testing on test server. So does it mean that we are doing testing parallelly on a prod?
No, no. See here, first parallel in the sense they're happening parallelly iteratively means developers wrote a code. Okay, whenever they wrote a code, it will trigger. It will trigger the pipeline. Means that code will be pulled, built, tested, deployed to first two test environments, then staging one after the other. Each environment it would be deployed one after the other, tested there before it goes to production.
So technically, if we have any code on a Git, so you're just deploying directly to Git, and then you need to just change the path for the prod, for the DevOps.
You have
With
to
the
deploy
DevOps.
it on prod servers. Prod servers will be different. You have to first deploy it onto test environments, staging environments, then deploy it to production environment.
Okay.
So it actually goes in a pipeline, like Jenkins
Yes,
takes deployment and
it
then it.
is a pipeline. Okay, it's a pipeline. Each stage means whenever there's a code change, this is happening. Like first means after deployments happen one after the other. First from lower environments to higher environments. Here I say deployment means first to the lower environment, then to the production, not directly to production. But it is automatic, means one environment after the other environment, it would be automatically deployed, tested there, and goes to production. Yeah, that's what. See, we'll see this practically. When you see practically each stage one by one after the other, you will get a more visibility on it. Okay, just understand DevOps is about a continuous process of moving your code to production automatically. For the first time, you create this CI/CD. Once this CI/CD pipeline is created, then the complete process could be automated with a single trigger. This trigger could be developer writing some new code, or else you could set some triggers, automatic triggers, schedulers for it. Right? Any more questions here?
Thank you.
So now that we understood what is DevOps and why DevOps came in, let us talk about the skill set a DevOps person should have. See here, yeah. See, like I said, DevOps is nothing but these three teams working together, and we discussed about waterfall methodology. You have all this documented, which you can refer after the class as a notes, and drawbacks of waterfall methodology, and then the Agile methodology and DevOps. Why DevOps? To have a collaboration between the teams, to automate the complete workflow without manual intervention, and to overcome the drawbacks of the traditional approaches. So we understood what DevOps is all about. Yeah, see here you could see the difference, like I have already shown you in waterfall design, after that coding, then testing and deploy. In Agile, design, coding, testing, but deployment was manual after at the end. But here if you see any new feature could be deployed, right? Any new feature deployed means code, it would be tested, built and deployed to the environments, any new feature. So this happens continuously. Now that we understood the, sorry, 1 minute. Yeah, we also understood the roles and responsibilities of a DevOps person. What does a DevOps person do? He would be working in the CI/CD pipeline. You might be allocated, you might be working at any stage in this pipeline. So you should know the complete pipeline creation and at any stage, how do you work? So all of them will be covered in this course. So, okay, fine, we will be automating this process, but where do we fit in? What are the tools needed, right? Let's talk about the tools and skill set. See, like I said, I have included all the tools which are having a great demand in the market right now. And yeah, basically a DevOps person should know a version control system. They should know build automation tools, continuous integration tools, containerization tools, infrastructure as a code tools, container orchestrator tools, continuous monitoring, and some cloud computing awareness. Okay. And here, version control system, I'm covering Git. There were so many tools under this category, like SVN is there, TFS is there, and so on. Under each category, there were so many tools. You need not learn all those tools, or you need not learn or work with all the tools. If you know one tool, you can switch to any other tool in the category very easily. Okay, because they all work with the similar concepts. Okay, and the similar configurations. Here I'm covering Git because Git is very widely used in the market. It's a very widely used in the market. It's having a lot of openings. Many of the modern DevOps projects uses Git. So I'm covering Git here. Every tool will be covered from the basics till advanced step, okay, including the architecture, including different types of tools in the same category. Like we'll talk about what are other tools, and then we'll be discussing each tool from the basics till advanced concepts, so that almost anything in regarding that tool you can answer in the interviews. So Maven will be covered, similarly Jenkins, Docker, Ansible and Terraform, Kubernetes, Docker Swarm. Docker Swarm is not having much importance in the market, but here we'll just have an overview of it. Okay, so that we can understand Kubernetes, and then Prometheus, Grafana, and AWS services, whichever required for DevOps. Of course, again, AWS services like code commit, code build, code pipeline, Elastic Beanstalk, S3 storage services, all of them will be covered. So this is the complete skill set. See, nowadays in the market, you are having like, there's a lot of demand for Ansible, Terraform, Kubernetes. These three combo can fetch you a job. Almost many of the projects are looking for these three tools. So see, if you master any tool, you can have a lot of openings, like you have a lot of options, lot of openings there. Right, and Prometheus, again, Prometheus is a great tool. Even Grafana is having a lot of demand in the market. So of course these are mandatory. Without knowing Docker, you cannot just jump into Kubernetes and all. So obviously Docker should be known. These are mandatory, and these are the tools you need to master. So which tools you need to master and all, we'll discuss. Any questions on this page, anyone? Any questions about any tools or anything here? Can I go on?
Ma'am?
And also, I believe you have got the course content by now. You can also go to the course content for all the topics in detail. So these are the tools. And one more thing, for learning DevOps, Linux basics are mandatory. Okay, I'll also cover those Linux basics in the course. If anyone completely new to Linux, whatever Linux basics we need, or that also I'll be covering. Okay, so yeah, this is the Cicd pipeline we are going to create in our class, and also we'll be creating it on multiple applications. And in this process of creating this pipeline, we'll also discuss different scenarios. See here, Cicd pipeline, which I'm talking about. Yeah, see, developers write the code and place the code in Git. See, what is Git, what is Maven, everything we'll discuss once we start with the tools. So just understand, developers place the code in Git. From there, Jenkins will pull the code, build it by using build automation tool like Maven, and test it by using any test automation tool like Selenium or JUnit, whatever it is. And of course, testers will write those test cases. Okay, those test case execution will be done in the pipeline. Okay, once it is working fine, it could be deployed to next environment like staging environment or whatever. Okay, and in this deployment process, Docker, Kubernetes, Ansible, Terraform could be involved, right? So what each tool does, we'll learn elaboratively. So many things are there. Okay, first what we'll do is, okay, let me finish this first. So deploy, once it is deployed, the application, the servers, infrastructure could be monitored with the monitoring tools like Prometheus, and could be visualized with the dashboards in Grafana. See, monitoring means it will monitor the metrics of the servers, application, and so on. But you should visualize it, right? You have to see what is happening, isn't it? Like what is happening, you want a great dashboard. That's what Grafana does. See here, may I know your name? I'm seeing your name as attendee. Request you to please join with your names. May I know Amit? Okay. Yes, Amit, here we are not learning Selenium. We don't learn here Selenium. We don't need Selenium. We are DevOps engineers. We are not testers. Testers will write the test cases using Selenium or UFT or a JMeter, whatever it is. They will write the test cases. and those test cases should be executed from the pipeline. That's all. You just need to know test case execution automatically. That we will learn. Okay, we will be not learning any test automations tools here like Selenium or UFT. We will be not learning any programming language like a developer. Okay, we are not developers. We don't learn here writing a code and all. Once developers, see here, once developer wrote the code, developers should be writing the code. Okay, testers will be writing the test case. Okay, let me put it this way. Developers write the code for the application. Testers, it could be manual or automation, they write the test cases. If it is automation test, they generate the test scripts. Okay, developers will write the code, testers will write the test case and test scripts. So now what I do, I pull the code, build it using build automation tool, run those test cases in the pipeline, deploy it using these tools, and then monitor. Okay, once monitoring is done, it could be sending a feedback to the respective teams. Of course, not always to development team, to the respective teams. And all this pipeline will be creating on AWS. First, see here, two approaches will follow in this course. Okay, one approach is we'll create this CI/CD pipeline like a kind of on-prem servers. Okay, without using any services. Then we'll also create this CI/CD pipeline using AWS services. So that what is the use of this on-prem kind of, if you know this, you can create the CI/CD pipeline or AWS or Azure or GCP on any platform. Also, I'll be creating pipeline with the AWS specific. AWS environment specific pipeline, so that you get exposure to do it on any cloud platform. See, there are so many tools, so many clouds and all. You need not learn all the tools in the same category. If you know AWS, you can easily work on with Azure or GCP. That's what companies are looking for. They don't look for a person who know GCP, AWS, Azure. The person doesn't exist. They don't need that also. What they want is, if you know AWS, can you be able to work on GCP on, because they're all similar. You should be proactively take up or switch to other tools because they work with similar concepts, similar way. So this is the agenda. From tomorrow on, what we'll do, we will be starting with the first tool in our pipeline. Okay, tomorrow we'll start with Git. First, we'll start with what is Git, why do we need it? Okay, Git architecture, then Git hands-on, complete hands-on from basics till advanced. Like I said, we may be spending some couple of days here, maybe 4 days or 5 days on complete Git. Once it is done, then we'll learn Jenkins, Maven, then we'll start the pipeline from here. Okay, once we create pipeline till this much, then go learn Docker, Ansible, then create this step and so on. So step by step, we'll be creating this pipeline in our entire course. So this is an overview or agenda of the course. Any questions in this part? Or any questions in the course? Like I said, yeah, I'll be teaching you Linux basics, and entire lab will be done on AWS. How to create a free account on AWS, how to connect those AWS instances, all of them I'll teach you again from the basics. Lab setup I'll help you with, and complete hands-on commands, everything will be shared with you from the Google Drive. And every day class recordings will be provided. Now, any questions from your end, please let me know. This is all about an overview on the demo.
Hi, ma'am.
Yes, hi Manju.
Ma'am, is it necessary to lead AWS before going to DevOps? No need, right?
It is not mandatory, but always good to have some cloud understanding, because almost companies are looking for it. Any cloud knowledge is good to have. But it's not mandatory, because some companies, they may be doing on-prem. Tell me.
Okay, you will be teaching some necessary part in AWS, right? Required to
Yes,
learn AWS. Yeah.
yes.
Okay, ma'am.
Complete CI/CD pipeline with the real-time scenarios, so that you can handle the interviews. All of them will be covered. Have you gone through the course content? If not, just let me quickly walk through the course content, so that if you have any more questions, I could
Yes,
clarify
ma'am,
them.
please. Yeah.
Yeah, see here what is DevOps. This is what we discussed today. Okay, that's the first small module. See here, then operating system and Linux basics will take up after Git. Tomorrow we'll be starting with this Git part. So what is a version control system? What are the types in version control systems? What is Git, Git architecture? How do you work with Git on Windows and Linux? Everything, lot of things in Git here. So that you could work with any concepts, anything in Git. Prashant, like I said, if you know working on AWS, it would be similar on Azure, but there is no separate class for Azure. Azure or GCP, if you know working on AWS, you can work on any other cloud platform. So then we have, yes.
This is Prashant, ma'am. I'm working on Azure DevOps, ma'am, but I didn't got any project interview. That's why I have to improve my skills on that. That's why I asked you that question. Really Azure based. Okay.
Okay. See,
I
like I
done that.
said, Azure, AWS, the concept services would be similar, just there'll be difference in the name. Okay, so
Yes,
if you
ma'am.
know AWS, how to work with the pipelines in the AWS, the same can be implemented to Azure.
Okay, okay, ma'am. Thank you.
And see here, these are the cloud concepts I'll be covering: IAM services, regions, availability zones, VPC, S3 storage service, EC2 service, load balancers, auto scaling groups, Elastic Beanstalk, ECR, ECS, EKS, and creating a pipeline on AWS. Not only this, there are few more AWS services at the end. See here. AWS code pipeline service, again you have a content here: code commit service, code build service, code deploy service, cloud formation service. Cloud formation service is also having good demand in the market. All of them related to AWS. But the flow, I'll choose the flow which best suits. So this is the flow we'll be going through. And the build automation tool like Maven, it's actually a developer tool, but whatever understanding overview a DevOps person should have will do that. And then continuous integration tool Jenkins. Jenkins is very easy tool actually, but very important. Everyone should know. So we'll be starting again from the basic, like installing Jenkins architecture, running the jobs, deleting the jobs, configuring the role-based access control strategy in Jenkins, best practice in Jenkins, plugin management, triggering the emails, scheduling the jobs, different ways of scheduling like GitHub webhooks, poll SCM, compile, test, deploy jobs, and so on. Right, and then the master slave architecture in Jenkins. Also, how to connect to private registries like ECR or on Docker Hub, how to connect to private registries from Jenkins file. We'll be writing a Jenkins file, which is a pipeline as a code concept. It's a Groovy script. So all of them will be covered. I think this one, yeah. And then adding Windows slave, Linux slave, multi-branch pipeline. Okay, have to have multi-branch pipeline type of a jobs. How do you do it with a Jenkins file in the realistic approach? Okay, and also how to deploy to EC2 instance on AWS using Jenkins pipeline. And then containerization tool. What are images? What are containers? Right, container Docker files, creating custom images, volumes for data persistency, connecting to private registries, right? Again, deploying Docker containers via Jenkins, that's where the integration part comes in. Okay, these are all advanced concepts. High availability, scaling, load balancing through Docker Swarm, creating custom overlay networks in the Swarm, multi-containers on Swarm cluster with the Compose, all these things are covered. And container orchestration tool, Kubernetes. Again, Kubernetes from the basics: pods, deployments, services, headless service, node port, load balancer, secrets, config maps, daemon sets, persistent volumes, volume claims, rolling updates, rollbacks using blue-green deployment strategy and canary deployment strategy. Above all this, Helm, which is a realistic approach which we use in the projects. Helm package manager for Kubernetes, deploying via Helm, deploying Prometheus, Grafana dashboards, and Kubernetes dashboard with Helm, and deploying microservice application using stateful sets. And again, deploying applications on Kubernetes via Jenkins integration. That also will be covered. Something I didn't mention here, that's about the Jenkins integration. And not only we are covering Kubernetes like on kind of prem, we are also covering Kubernetes on AWS by using a service called EKS. EKS means Elastic Kubernetes Service, which is a paid service. Because that is how you use in the project, I'm also covering this paid service of Kubernetes. Okay, this is having a lot of demand in the market because 50% of the Kubernetes clusters are using EKS. So you know how widely it is used. So lot of job openings are there if you know the CKS service, which also I'll be covering. I'll also cover auto scaling feature, okay, and also deploying. See, that's where CI/CD Jenkins integration with EKS cluster. How do you deploy applications in the Kubernetes cluster via the pipeline? Isn't it? It's not you deploy manually. You should also deploy it through Jenkins pipeline. I mean CI/CD pipeline. So even that part will be covered. These are all far advanced concepts which take some time to cover these concepts. And then Terraform. Again, Terraform from the basics till you create, automate your infrastructure on AWS. If you know how to use Terraform to build the infrastructure on AWS, you can do it on GCP or Azure on any platform. And so modules concept in Terraform, it's an advanced part. And also not only building the infrastructure with Terraform, you should build it in the pipeline. Means whenever there's a new change, servers should be built automatically and you should deploy it. Even that part will be covered. Automatic provision of EKS cluster on AWS with Terraform. Okay. And then Ansible architecture, push configurations in Ansible playbooks, modules, roles, Docker container deployment with Ansible, Docker compose deployment with Ansible also will be covered. And complete CI/CD on Jenkins. It's a too huge, a lot of content, many things are there. You may not be having a clear idea of what these topics are all about, but to just have some overview, I'm going through it. Don't get confused. Everything will go step by step. Then Prometheus architecture, again monitoring Kubernetes cluster with Prometheus, configuring dashboards for Prometheus and Kubernetes metrics and Grafana. Grafana is having a lot of demand in the market. These days I saw so many job postings with a description saying Prometheus monitoring tool and Grafana. Only these two tools. Experience with it. These two tools are having so many openings. You can check it out in the job portals. Okay, Grafana particularly, because Grafana can be integrated with any system, like not only Prometheus, it can be integrated with Elasticsearch, it can be integrated with database. You can create custom beautiful dashboards with Grafana. So if you know building dashboards with Grafana, you have a lot of scope. Okay. And then the code pipeline service. Using code pipeline, how do you build the pipeline? Till now we have seen pipeline using the tools like Jenkins and all. Now create the pipeline using AWS services. How do you do that? Even that will be the covered. So that what you know the AWS, these are called developer tools or DevOps tools of AWS. Sure, Manju, you can call me, you can reach me on WhatsApp. Any questions you have from here, you can ask me now, or else you can reach me on WhatsApp. You can call me on the WhatsApp number. And anything else? Any questions from your end? This is my contact number. You can reach me on this number or you can message me. And the class continues from tomorrow at the same time. It will be 7 to 8:30 a.m. as it's the first day. We just got an overview. Tomorrow I'll be starting with Git. So get confirmation, like confirmers, if you want to continue, go through the registration process and you can join from tomorrow. Any questions? Anything else from your end?
Ma'am, can I call you soon after the meet's end?
You can, please.
Oh, okay, ma'am. Thank you.
All right, then bye everyone. Have a great day. Thank you all for joining.
Bye, ma'am.
Bye, ma'am. Take care.